In this recording, we will compare the electrical potential energy to the electrical potential. An electrical potential energy is the energy of a charge at a certain location where there is already an electrical potential. Or, to speak of electrical potential energy, you have to speak of two charges or more. The energy associated with the forces that these charges exert on each other. However, for electrical potential, it is found for a particular location only, and it can be due to only one charge. We can have an electrical potential due to numerous charges, but you need only one charge to have an electrical potential, and it would tell us what the electrical potential energy if we place a charge in that location. Then the electrical potential energy, we can just calculate it by multiplying the electrical potential by the charge. So this is the difference between electrical potential energy and electrical potential. Electrical potential does not tell us of an energy. We need to bring in another charge to where that electrical potential exists to have an electrical potential energy, and then the electrical potential energy is just the electrical potential times that charge. Neither the electrical potential or the electrical potential energy is a vector. Both of them are scalars, but the sign is going to matter. For example, the electrical potential due to a negative charge is always negative. The electrical potential due to a positive charge is always positive. Usually, we are going to have to worry, like for gravitational potential energy, we are going to have to worry only about changes in electrical potential and changes in electrical potential energy. We are not going to worry about absolute values. But in some cases, like in the examples we'll work in this chapter, we'll worry about the absolute values. Now, we need to be careful in dealing with voltage and electrical potential energy, especially how to be careful with the signs. Whenever we deal with electrons or negative charges, since the charge is negative, that means that the potential due to those charges is going to be always negative. 0 being the highest potential. Okay, now, if we move a negative charge from a region where I have a positive electrical potential to a region where I have a larger positive electrical potential. So I'm taking a negative charge, I'm moving it from an electrical potential, positive electrical potential, to a higher electrical potential. The change in electrical potential is positive, but the change in electrical potential energy is negative. It's Q times the change in electrical potential. What does it mean? It means that the negative charge loses electrical potential energy when it moves to a location with a higher potential. Now, how else to think about this? If we move from a positive VA to a larger VB, let's think about the electrical field. So if I have here VA, position A where I have VA, and a position B where I have VB. Now, if you think about the electrical field, remember the electrical field goes downhill. So it means my electrical field is pointing this way. And I'm going to take a negative charge, so meaning the electrical force is going to act on it this way. Now the electrical force is acting on it this way. That means it's going to be accelerating towards VB. It's like it is falling towards VB, the location of VB. So it is losing electrical potential energy. And that's what we see here. Again, so to explain that, when a negative charge is placed in a region where there is a particular potential, it will accelerate towards the region of higher voltage, losing electrical potential energy and gaining kinetic energy in the process. That's what we just talked about. Essentially, like a mass, when you put it in a higher location and you let go of it, it's going to roll down, or it's going to accelerate to the lower level, losing gravitational potential energy and gaining kinetic energy. So for a negative charge, it's going to move towards higher voltage, losing electrical potential energy in the process. Now for positive charges, the story is a little different. Now, the voltage, the electrical potential, is always positive. 0 is our lowest potential. Now, if a positive charge is moved from a positive electrical potential to a higher electrical potential, again, the change in voltage is positive. However, the change in electrical potential energy is also positive, meaning that it is gaining electrical potential energy. Again, if you think about it in terms of electrical field, if my electrical field is pointed this way, if it is a positive charge, it means that the force is going to act on it this way. So when we moved it towards point B, we were opposing the electrical field, giving it more electrical potential energy. So when a positive charge is placed in a region where there is a particular potential, it will accelerate towards the region of lower voltage, not higher voltage, it's the opposite, losing electrical potential energy and gaining kinetic energy. So that's the major difference. A negative charge will accelerate towards the region of higher voltage. A positive charge will accelerate towards a region of lower voltage or lower electrical potential.